Hello everyone! This time I will discuss very important topic. The role of statistics in disaster management. Please don't forget to subscribe on my channel.
So, I'm going to discuss the role of statistics in the Philippine disaster management. So, a country like the Philippines where typhoons, floods, and earthquakes are part of our life, statistics plays a crucial role in saving lives. So, this channel is dedicated to students, teachers, researchers, civic leaders who want to understand how data and statistical tools can improve disaster preparedness, response, and recovery. Of statistics in the Philippine disaster management. So turning data into life-saving decisions. So we all know that the current challenges Philippines experiencing in terms of disaster risk management. So we have floods, we have typhoon. So how can numbers save lives? So in the Philippines, one of the most disaster-prone countries, statistics plays a vital role to every phase of disaster management. Why? So we have here average of 20 typhoon per year. We have storm surge threat. We have volcanic eruptions since 25 active volcanoes in the Philippines. We have floods and droughts and even earthquakes and landslides and the human-induced disaster. So even this can interrupt our power and water supply. And we are going to take care of the attitude and practices of communities during the disaster risk management committee or even our government. So why statistics matter? So we have the formula, the general formula, statistical literacy is equal to disaster preparedness. So based on the guidelines in assessment of information of the statistics education, statistics is essential for decision making in uncertain situations. Why every decision during disaster rely on real time and historical data. So in the Philippines, since this is a disaster-prone archipelago, why this comprised of 7,600 islands in the three main geographical divisions, Luzon, Visayas, and Mindanao. And we have the geographic vulnerability situated in the Pacific Ring of Fire and the typhoon belt, making it extremely prone to earthquake, volcanic eruption, typhoons, floods. So in the biodiversity and livelihood, around 52,000 species. This biodiversity is vital for food, our security, tourism, and agriculture, adding complexity to disaster preparedness. So the risk management, we have the different government agencies like the National Disaster Risk Management System. We have the PAG-ASA and the FIVOLCS employ advanced tools like the government information system and the remote sensing for planning and response. We are going to discuss the four phases since we all know that we have here profile, description, estimated cost of disaster per year in the Philippine economy, around 85 to 422 billion. Why? We have 836 from 1905 to 2017. We have noted 837 disasters, around 81,000 people killed, 219,000 people injured, and we have 204 million people affected, and we have 6 million homeless, 210 million total people affected. So around total estimated damage from 0.5 to 3% of our GDP. So in the number of Filipino affected by natural and the human-induced disaster per year, we have around 12.1 million. So what are the four phases of disaster management? We have first is the mitigation. We have the mitigation, the risk mapping with spatial data mining. So we have the data mining that help adaptive risk map, providing real-time situation awareness for early warning signals. So we have the hotspot analysis. This is identify high-risk hotspot, analyzing the concentration of past events, guiding where mitigation efforts are most needed. So we have also the machine learning model. This predicts spatial distribution of disaster risks. So example, in the Philippines based on the environmental variable for targeted intervention. And even the multivariate modeling for infrastructure after any calamity. So analyze the multiple variable to inform the preemptive planning of resilient infrastructure and minimize future impacts. So we have this from the big data volume, the unprecedented vast data available for decision making. So we can create from the diverse data types, from the varied sources of our text, spatial, our government information system. We have the satellite and the social media. So these are the real-time velocity or high speed. We have a rapid data generation and decision making. So the role of data in disaster predictions, we have here the role of data in disaster prediction. This is a review of application data mining techniques to combat natural disaster. So we can graph highest here so far from the Google Scholar: earthquake, flood, we have landslide, storm, tsunami, cloudburst, and volcanic eruption. So second phase is preparedness. So we have some application. We have data-driven application that can help for preparedness. We have the deep learning from satellite images. This can really help. Advanced typhoon prediction model. So this time we are now in the advanced. Impact-based forecasting, the ABF, and the anticipatory actions. So in the deep learning learning from satellite images, this can help analyze our vast satellite or cloud imagery, enabling highly accurate and timely identification of developing weather phenomenon for our early warning signals. And we have also the advanced typhoon predictions using the GCL STM, the Congru to process complex satellite data forecasting typhoon path and intensifies with remarkable precision. So, and the IBF, this is a portal translate meteorological data into actionable insights on potential impacts. So, provides decision makers with a clear, localized information to facilitate proactive measures. And these anticipatory actions like the predictive maps, our Google Maps, from our artificial intelligence or any application in our cell phone, this model trigger early actions like the resource or pre-positioning and evacuation center that we are going to offer, as seen in the effect response from the Typhoon Kanmuri in the Philippines. So from this, we can prepare ahead and we can we have now greater than 95% typhoon prediction accuracy. So more or less, they are accurate. And then the primary data sources from the satellite images, this is the foundation for deep learning models. And of course, the early action to save life, of course. So phase 3 is the response. So we have so far for the response, harnessing the real-time data for effective action agad, action immediately. So from the text and social media mining, so we can use social media platform become crucial in social sensors. So we can extract real-time information for rapid situation awareness and assessing needs faster than traditional methods. So this assessment is faster than the information before. We have classifying and prioritizing tweets or chats or even social media information, video uploading. So algorithm filter massive tweets volume that with around 91% recall. This ensures responders focus on the most, are going to focus on the most urgent needs. Or they have this clustering needs with support vector machines. So cluster the information to identify common themes like the shelter, the food, and the rescue. This is for efficient resource allocation. And the real-time information for responders. The ultimate goal is providing actionable intelligence. So rapid analysis of social data gives teams up to the minute updates. So very early updates or timely updates, of course. Early updates significantly improve the response coordination. So we have phase 4 is the recovery. So during the recovery, we can use data like the disease and outbreak predictions. So early. This enables proactive public health intervention, especially for crises like the dengue. So another is the predictive risk modeling, the logistic and multiple regression. You can predict, applying regression model to forecast and predict of diseases like the COVID-19, the dengue, or any diseases. We have the spatio-temporal analysis. What is this? Utilizing the geotag Twitter data with time series model. So this will analyze disaster impacts and recovery progress, providing insights into affected areas over time. And the fire incident profiling. This is key means clustering, employing the clustering the profile fire incidents, example in Manila. So identifying patterns to improve resource allocation and inform urban planning for fire prevention. So these data mining techniques in disaster management application areas, we have three: in the prediction, in the detection, and disaster management strategy. So this really can help. The data mining techniques can help in the three application areas: predict, detection, and apply disaster management. We have an example, the case study forecast model during the that can reduce typhoon risk. We have here greater than 95% accuracy by the GCLSTM model by processing complex spatiotemporal data from the satellite imagery. And this model predicts typhoon intensity and path with remarkable precision, providing critical lead time. And we have integration with IFRC map. These maps impact-based forecasting map that translating raw data into actionable issue of potential impacts for targeted humanitarian resources. Another is actionable early warning. So it must be early warning. The system generates crucial early warning up to 72 hours before landfall. This is a vital window for implementing effective preemptive measures and community preparation. Like they're going to prepare evacuation, they're going to prepare their food, and enabling early action. So this is a case study for enabling early action. Timely warning allow us for early harvesting of their farms, farm products, and organized evacuation of vulnerable people or vulnerable populations. And of course, this can minimizing loss. Proactive measures lead to substantial reduction in casualties and of course, property damage. This can really help. So we have the impact example of an impact-driven, data-driven alerts. So from the typhoon forecasting pipeline, it can be from the satellite imagery, from the GCLSTM model and the forecast map, or the early action, the local early action. We have an example during the 2011 this project, the NOAA Success Project, this is the nationwide operational assessment of hazards in the Philippines. This is a prime example of data-driven disaster management. Why? During the Typhoon Sindong, there were around 676 mortality cases of mortality rate. But after the NOAA's implementation project, there are only death from 676 during the Sindong. There were only one death in Typhoon Pablo in 2012. So there is really a result. There is really an impact. Okay, so you may comment, how has the data helped your community during disaster? So you're going to reflect. We have questions for reflection. How has data helped your community during a disaster? Please comment down and watch my next video on turning data into forecast and decision statistical tools in action.
Thank you for watching. Please subscribe on my channel.